Imagine you're standing on Earth 4 billion years from now. The sky above you is wrong. The sun doesn't look like the sun anymore. It fills a quarter of the horizon, swollen red, pulsing like something alive and wounded. The oceans boiled off centuries ago. The ground beneath your feet glows faint orange, and the air, if you could call it air, is a thin, scorching haze of carbon dioxide that would cook your lungs in a single breath. You look up at that monstrous dying star, and you realize something that freezes you despite the heat. This was always going to happen, and NASA has known the timeline for decades. Right now, today, if you step outside and look up, the sun looks perfect. It looks stable, reliable, almost friendly. It rises, it sets, it gives you warmth, it grows your food, it lights up everything you've ever loved. Every civilization in human history has worshipped it, painted it, written songs about it. It feels eternal, it feels safe. But something is deeply, fundamentally wrong with the sun. Not in the future, not in some abstract theoretical sense. Right now, at this very moment, the sun is dying. It has been dying since the day it was born, and the process that will eventually destroy everything you know is already underway. The clock started ticking 4.5 billion years ago, and we are closer to the end than we are to the beginning. Here's what most people don't understand. The sun is not a ball of fire, it's a bomb. A continuous, sustained thermonuclear explosion held together by its own gravity. Every single second, the sun converts 600 million tons of hydrogen into helium in its core, releasing energy equivalent to 91 billion megatons of TNT. That is not a metaphor. That is not an exaggeration. Every second. And the only reason it doesn't blow itself apart is because its own mass, 330,000 times the mass of Earth, crushes inward with enough gravitational force to contain the explosion. It's a war. Gravity pulling in, nuclear fire pushing out, and for now the two sides are balanced. But that balance has an expiration date, and this is where things change, because the sun is running out of fuel, not tomorrow, not next century, but on a timeline that is already measurable and already accelerating. Every second that passes, the core gets a little more clogged with helium ash. Helium is heavier than hydrogen. It sinks to the center. It builds up like sediment at the bottom of a river, and as it accumulates, the core has to work harder. It compresses tighter, it burns hotter. The sun right now is roughly 30% brighter than it was when life first appeared on Earth. 30%. That might not sound like much, but it has already changed the chemistry of our atmosphere, already shifted the boundaries of our habitable zone, and it's only going to get worse, much worse. But here's the problem. This isn't a slow, gentle process. The sun's brightness increases by about 1% every 100 million years. That means in roughly 600 million years, the sun will be hot enough to trigger a runaway greenhouse effect on Earth. Not the kind we argue about in politics, the kind that turns an entire planet into Venus. The oceans will begin to evaporate, not slowly drain, evaporate. Water vapor will flood the atmosphere, trapping more heat, which evaporates more water, which traps more heat, in an unstoppable feedback loop that will strip this planet of every drop of liquid water. The surface temperature will climb past 150 degrees, then 200, then higher. Every river, every lake, every aquifer gone. And with the water goes every living thing that ever depended on it. That is not the death of the sun. That's just the preview. But it gets worse. Because what comes after the water is gone is something far more terrifying. As the sun continues to age, as the helium core continues to grow and compress, the hydrogen burning shell around it will push the outer layers of the sun outward. The sun will begin to expand, slowly at first, then faster. It will swell past the orbit of Mercury. Mercury won't be consumed. It will be vaporized, disintegrated into atoms before the surface even reaches it, because the radiation alone at that distance will be enough to melt solid iron. Then Venus. Venus will be swallowed whole, pulled into the expanding plasma like a pebble sinking into lava. And then the sun will keep growing, bloating into what astronomers call a red giant, a dying star that is paradoxically larger and more luminous than it ever was in its prime. At its peak, the red giant sun will be roughly 250 times its current diameter. It will fill the sky from horizon to horizon, and Earth will sit right on the edge of its reach. And this is the part NASA doesn't emphasize in the press releases. We don't actually know if Earth survives Some models say the expanding sun will stop just short of Earth's orbit. Others say it will engulf our planet entirely. But here's what both models agree on. It doesn't matter, because long before the sun's surface reaches Earth, the radiation will have already done the job. The atmosphere will be gone, the crust will be molten. The planet will be a glowing, featureless ball of magma orbiting inside the outer envelope of a dying star. Whether the sun technically swallows Earth or just cooks it into oblivion is a distinction that means nothing to anything that ever lived here. But that's not even the worst part, because the red giant phase is not the end. It's the beginning of something far stranger and far more violent. When the sun exhausts the last of its hydrogen fuel, the core, now a dense ball of helium, will collapse under its own gravity. The temperature will skyrocket to over 100 million degrees. And at that temperature, something new ignites. The helium itself begins to fuse, slamming together to form carbon and oxygen. But this ignition doesn't happen gradually. It happens all at once in an event called the helium flash. In a matter of minutes, the core releases energy equivalent to the entire galaxy's luminosity. The entire galaxy, in minutes. The star shudders. The outer layers convulse. And for a brief, violent moment, the sun becomes something unrecognizable. After the helium flash, the sun will settle briefly into a smaller, more stable form, burning helium in its core. But this phase lasts only about 100 million years, a blink in stellar time, and when the helium runs out, there's nothing left to burn. The core isn't massive enough to fuse carbon. The nuclear fire that has burned for over 10 billion years simply stops, and when it stops, gravity wins. The core collapses into a white dwarf. An object roughly the size of Earth, but with the mass of the sun. A single teaspoon of white dwarf material weighs about 15 tons. It's so dense that the atoms inside are crushed together, their electrons squeezed into a quantum state called degeneracy, where the laws of physics you learned in school simply stop applying. But here's what haunts me about this. As the core collapses, the outer layers of the sun, all that gas, all that plasma, everything that isn't nailed down by gravity, gets ejected into space. It expands outward in a shell of glowing gas called a planetary nebula, one of the most beautiful objects in the known universe. From a distance of a few light years, it would look stunning. A glowing ring of color against the blackness of space. And at its center, a tiny, impossibly bright point of light. The white dwarf, the corpse of our sun, still glowing from residual heat but generating no new energy. Slowly, over trillions of years, it will cool, it will fade, it will go dark. And when it does, it will become what physicists call a black dwarf, a cold, dead husk of matter drifting through space, invisible, silent, forgotten. And here is the thing that should keep you up at night. No black dwarf has ever existed. The universe is not old enough. It takes so long for a white dwarf to cool completely that not a single one in the entire observable universe has finished the process. The oldest white dwarfs are still glowing. The universe is only 13.8 billion years old, and it takes quadrillions of years for a white dwarf to go dark. That means the death of our sun, Tatuenso Tatakamara, the true, final, complete death, hasn't pericons. Azenauketa hasn't happened to any star, anywhere, ever. We are predicting an ending that the cosmos has never once produced. We are staring at a fate that exists only in mathematics, a destiny written in equations that no telescope will ever confirm, because no one and nothing will be around to see it. And yet there is something strangely honest about all of this. The sun was never permanent. It was always a temporary fire, a brief flicker of nuclear light in an ocean of darkness so vast that the word infinite feels too small. Everything that has ever lived on this planet, every empire, every love story, every war, every song, every moment of wonder you have ever felt, all of it was powered by a star that was always dying. We just happened to show up during the good part. We built our entire existence in the space between ignition and collapse, and we called it home. But the sun doesn't care about us. It doesn't know we're here. It burns because physics says it must, and it will die because physics says it must. And nothing we build, nothing we believe, nothing we hope for will change that by a single second. The universe was never built for us. We just borrowed a little light from a fire that was always going out.